This is Steady State Exercise 2.2. There are three different types of hypothesis. The first one being a null hypothesis. This is where there is no significant difference in the results. The second being a two-tailored hypothesis. This is where there can be two possible outcomes that are different that are thought to happen. The last hypothesis being a single-tailored hypothesis. This is where there is only one outcome that is predicted instead of two. Our hypothesis consisted of Summer's heart rate will initially increase in comparison to rest, but will then plateau after 3 minutes. Our second hypothesis was we also predicted that during steady state exercise there will be a low amount of lactic acid, where we can measure this by using the lactate monitor and O2 saturation. We finally predicted that Summer's breathing rate will initially increase, but at the minutes 3 to 18 the breathing rate will plateau. Our method consisted of Summer cycling on the exercise bike for 20 minutes, while trying to work at 60 to 70% of her maximal heart rate of 184 beats per minute. While this took place, we recorded her heart rate every minute, her blood pressure every 4 minutes, and her O2 saturation and breathing rate every 2 minutes. We also asked her how she was feeling every 4 minutes on a scale from 1 to 20. We would measure her lactate at 3, 12, 16, and 20 minutes. Here we can see that after minimal exercise for 2 minutes their heart rates had increased, and then by 8 minutes they had all increased quite drastically, with two clients, Summer and Max's heart rates had more than doubled. Then their heart rate started to plateau with some decrease and increase. We can also see here that Josh's heart rate at the start of the exercise decreased instead of increasing. This could have been to having a slow start, or the data was just recorded wrong. This isn't the only part of data from Josh, as his heart rate before started exercise is at 105, which isn't normal for us. Summer and Max's are very similar to the normative data, especially Summer's. This is because at the start of the exercise, for the normative data, their heart rates tend to increase steadily at the start, and then around halfway, the heart rate starts to plateau, and then once the exercise has been completed, their heart rate drops a bit lower than where it was during the exercise, but nowhere near to their original heart rate. This is what happened to Summer and Max's, but not for Josh, as he had a slower start and only managed to hit his top heart rate by 20 minutes. This was affected because Josh did a warm-up that was at a higher intensity than the steady state exercise was, so therefore his heart rate started higher than it should have normally, so then dropped once he started the lower intensity exercise. Blood pressure. Here we can see in the systolic blood pressure graphs that Summer and Max's data is very different. I know from the normative data for systolic blood pressure that it gradually over time increases but not drastically, and doesn't decrease at any moment in time. As we can see here that this isn't the case for either Summer or Max. Summer's was similar, as it gradually increased until 14 minutes, where it starts to slowly decrease. Despite this, her blood pressure at the start and throughout the exercise isn't how it normally is, as hers starts at around 85, whereas it normally starts around 130 and increases from there. However, Max's starts at 145, which is normal, but instead of increasing, it decreases quite drastically by 45 in 8 minutes. After this, in the next 2 minutes, his blood pressure increases by 80. This shows us that his blood pressure probably wasn't recorded properly in the first 8 minutes, as it isn't normal for it to decrease and then all of a sudden increase by as much as it normally increases throughout, but only gradually. This is the same outcome for the diastolic blood pressure, where Summer's does increase throughout and then plateaus, whereas Max's decreases throughout and then plateaus afterwards at around 14 minutes, the same as Summer. During steady-state exercise from the normative data, the participants' O2 saturation should remain pretty constant with little change throughout and should always be around 99%, and after the exercise has been completed, their O2 saturation still shouldn't have changed much. Here we can see that they all started off at around 99 and remained pretty constant throughout the full 20 minutes. Despite this, we can see that Max's data is different to this. We can see that around 12 minutes Max's O2 saturation dropped by more than 10 and then went back to how it was after around 3 to 4 minutes of this. This is very abnormal to happen and may have happened due to how it was being recorded or the equipment that was being used to record the data. However, this did not happen for Summer or Josh, and their data shows us that it was very similar to the normative data as it stayed around 99 and was constant throughout the whole 20 minutes and pre and post 1 minutes. When performing steady-state exercise from the normative data, the participant's blood lactate shouldn't increase too much due to it being an aerobic exercise and not much lactate acid should be produced. They should also start at 0 before any exercise has started, which happened for all of them. This all happened for Josh like it should, but for Summer and Max, after 2 minutes their blood lactate shot up to 16 and 12. This is normally what would happen if someone was taking part in anaerobic exercise, which suggests that at the start they might have been working too hard, which led to an increase in lactic acid being produced. After the 2 minutes, Max's and Summer's blood lactate begins to plateau, especially Max's. After 10 minutes, Max's and Summer's blood lactate drops, but at 16 to 20 minutes, Max's carries on dropping all the way to 2, but Summer's increases again to 17. This isn't what happens in the normative data, as it is supposed to stay constant with little increase during exercise in blood lactate. This may have happened for Summer due to her starting to work harder than needed towards the end of the exercise, and for Max at the start of the exercise. The normative data for someone's rating during steady-state exercise would be: as the race goes on, the participants' rating will increase, but not massively, as they are not working that hard, but are working for a long period of time, so it will get harder as the exercise goes on due to them getting tired and not having as much energy as they would have. As we can see from the chart, this happened for Josh, as it shows us that during the exercise his rating was always increasing, but not by much each time, as over the 20 minutes it only increased by 6. On the other hand, you could say this increased a bit too much than usual. Despite this, for Josh, Summers and Max's results from this were very similar but different to the normative data, as they started at a much higher level than Josh, which may have been because they would have been worked at the start for not knowing completely what levels to work at. This then meant that over time their ratings decreased. From 4 to 12 minutes, Summer's rating went up by one or more, but after that only decreased. This shows that they weren't working as hard as they were at the start, and therefore not finding it as hard, which led to their ratings dropping. For Summer and Max, from 16 to 20 minutes, their ratings plateaued, which is normally what happens. The normative data for breathing rate during steady-state exercise shows us that from the start of the race to the first few minutes their breathing rate will increase, but then after around 4 minutes it will start to slowly plateau. This is what happens for Max, but his breathing rate starts at a higher level than usual, which suggests that he was working at a higher level than required. Despite this, his breathing rate increased by 6 in 6 minutes from 2 to 6 minutes, and then eventually plateaus and then slowly decreases after 12 minutes, but only by 4 from 12 minutes to 20 minutes. We can see here with Summer's results that the slow increase happens at the start like it usually would, but instead of plateauing after 8 minutes, there's a more sudden increase in her breathing rate by 5 in 4 minutes, and then from 12 to 16 minutes it drops again by 7 and then increases again in the last 4 minutes by 3. So from this we see that Summer's breathing rate never plateaus, which isn't what normally happens and could have been caused due to her not going at a steady pace and going quicker and then slower at different times. On the other hand, Josh's data is very different. At the start of the exercise, up to 4 minutes, there is an increase in heart rate by 8 and then decrease by 4. After his breathing rate doesn't plateau always as it is always increasing, but very slowly as it increases by 6 over the course of 12 minutes. The energy systems produces the majority of our energy while we are at rest or taking part in low intensity exercise. When this system takes place, mitochondria occurs. This is where both Krebs cycle and the electron transport chain takes place in organelles, which is mitochondria. The majority of ATP is produced in these organelles and are very important for energy production as this system provides ATP at a slower rate than the other two systems. They are rod-shaped and have an inner and outer membrane. The inner membrane is arranged into many folds that project inwards. These folds are called cristae and give a large surface area for energy production to take place. Our method to score the energy systems was using the oximeter to measure the O2 saturation and using the lactate measurer to measure blood lactate. The normative data for the O2 saturation shows us that it stays between 95 to 99% throughout the entire exercise, so plateaus throughout. However, for blood lactate, it shows us that there will be a small increase, but will remain at a low level. From our results, we can see that this did not happen for Max. This was because he was working too hard, therefore his lactates level were too high. We can also see this was the case from his RPE levels being too high as well during the exercise. We can also see that at 12 minutes, Max's O2 saturation drops drastically. This would have been to do with him working too hard at the start, but affecting him as he stopped working too hard, so therefore his O2 saturation dropped due to the change. From the blood lactate graph, this shows us that Josh's lactate levels were similar to the normative data, but Max's and Summer's were completely different as they were increasing massively and also decreasing massively throughout the exercise, which shouldn't happen at all until the exercise has been completed. During the test, we had numerous devices measuring the client's heart rate. These including a heart rate watch, blood pressure monitor, and also an oximeter that recorded O2 saturation as well. Out of these, the most reliable for measuring someone's heart rate would be the heart rate watch. All groups took the heart rate of their clients every 2 minutes so we can see the difference in their effort levels throughout the whole exercise. For heart rate during steady state exercise, the normative data shows us that there is a rise before exercise. This rise isn't huge but does happen due to an anticipation of exercise. Then once exercise starts, for the first 3 to 4 minutes there is a rise in the participants' heart rates, but then after this their heart rate will plateau. This happens due to the body systems meeting their demands prior to exercise and them not being able to work any harder. At the end of exercise, the participants' heart rates will then decrease eventually and be back to normal. This happened for 2 of the 3 participants, but as we can see from the data, there was still an increase in heart rate for Josh, as well as it just happened for a longer duration and never plateaued. For Josh's data, we can see that his heart rate decreases at the start of exercise. This is prior to him having a warm-up before the exercise that would have been at a higher intensity than the actual exercise. Despite this, Max's data shows us that was very similar to the normative data bar. The fact that his heart rate did decrease before exercise ended. This was prior to the fact for the first 10 minutes he was working too hard. We can also see in his RPE at 8 minutes he is working at an RPE of 16, whereas he should be working at an RPE of around 10 and not be finding it too full on or hard, which isn't the case for him. However, Summer's heart rate is the only one out of the three that shows an obvious plateau, as Josh's and Max's shows lots of change during the exercise after 4 minutes.